Greetings, fellow explorers. This is Tony with Fount Systems Network, and we are here in pursuit of low-carbon innovations for industrial wastewater treatment. Today, I'm very happy to welcome Raja Shazrin Shah to our network. Mr. Shah is a PhD candidate in chemical engineering at University Malaya, and he's doing original research into advanced treatment methods for wastewater from palm oil manufacturing. Malaysia is one of the largest producers of palm oil in the world, and it turns out that the wastewater resulting from its manufacture is, in Mr. Shah's words, really nasty stuff. His research centers on a novel hybrid moving bed biofilm membrane bioreactor treatment technology. You're probably already aware that membrane bioreactors are pretty standard pieces of equipment in wastewater treatment, but Mr. Shah's research is looking at ways of improving efficiency of the process while opening up opportunities for reclaiming nutrients. Before we look at what he has to describe, if you like what you see here on the Fount Systems Network, do like and subscribe to the channel. Now let's listen to what Mr. Shah has to say.
I was looking forward to our conversation today.
Okay, that's good to hear. I've been talking since morning, so yeah, that would be good too. Something a little lighter, I hope, with you. I don't know if I've mentioned that I'm doing my PhD.
Yes.
In wastewater treatment technology. So I'm looking into using biofilms to reduce fouling in membrane bioreactors. So we all know that when you talk about membrane bioreactors and MBRs, we are always fearful of the fouling that you're going to get during your operations. And a lot of this, when you're treating biological wastewaters, a lot of the fouling will come from biofouling. And we are thinking by introducing biofilm into your system, it will help reduce the fouling. And how we introduce the biofilm is by introducing biocarriers, beads that are made of PVA, polyvinyl alcohol, which provides like a very good home for a biofilm to attach to on the outer surface. It's actually a very unique system on its own, not just for working with MBRs, because when you use polyvinyl alcohol, PVA beads particularly, it provides like a dual function kind of thing, where on the outer surface you get a healthy growth of aerobic microbes, and on the inside of the beads you get an anaerobic kind of microbes growing inside. So you get both the nitrification and denitrification happening in one chamber. It's mostly suspended in the mixed liquor. Okay. The beads are like, they look like styrofoam beads exactly. So it's almost nutribuoyant. It doesn't float like styrofoam. The specific gravity is 1.01, 1.02. So with very little agitation, it will just float around. So normally what happens is the sparger will also serve as a mixer, where the movement of air inside your reactor will assist in moving the beads around. And also on top of that, by having biocarriers, you're able to push your bioactivity past your normal MLSS. You can increase the microbes concentration per volume of your reactor. You still have your membrane plates.
Oh, you still
in your configuration. Yeah, you still have your membrane plates. It's just that it's not just sitting in the wastewater, where you also have the beads moving around.
Okay, so the beads are added to, I see. Okay, are added to the mix. Okay.
Yeah. So now it becomes, instead of MBR, it becomes an MBB MBR.
There you go.
And I do want to work on real industrial wastewaters. Particularly, I'm looking at using palm oil mill effluent, which is kind of challenging. Yep, but I hope that it will work. The palm oil fruit, it comes in a big bunch with little fruitlets.
Yeah.
So the fruitlets are made of a flesh.
Yes.
It's like cherries, There's a pit, and the palm oil comes from the flesh. Actually, a lot of the wastewater from the palm oil is coming from the sterilization, the sterilizer condensate, where the fruit bunches are being loaded onto trucks, and they go in. It's like a train actually. they go into these large sterilizers, and they use steam to actually sterilize it, of course, and actually it's like a cooking process as well,
right,
where the flesh gets softened up and things
right,
like that. So
it makes I think it makes the oil flow more smoothly.
Correct.
Yeah,
It helps the extraction process. Palm oil meal effluent, pome, we call it. Pome being pome, it's not easy. Nothing survives when you put in there. And when you put something in there and you leave it for a long time, nothing survives. You put pH meters or DO meters, dissolved oxygen. It would just break. It's a really nasty business.
it breaks the sensing equipment. And so if you were to get a sample of wastewater and you're going to do a characterization study, what would you find?
So you're going to get CODs going up to between 80,000 to 120,000 milligrams per liter of COD. And you're going to get very high oil content. And the raw sludge comes out at about 60 degrees. The pH is going to be at 2. So yeah, it is really nasty business. And the solids content is high. But for my research, I'm not targeting the raw, because normally at a palm oil mill, the raw effluent goes to the first pond, where the mill will normally try to do a little bit of oil recovery. So oil is never good for membranes. So we don't want to put really oily wastewaters into a membrane system. So after that, it will go into another pond where some neutralization or equalization takes place. This is when the bugs start to grow and things like that. Then the pH gets adjusted to 7.
Okay.
That's when it can actually be treated. So I'm thinking of taking the effluent from there to be introduced into the system. Because as it is, most of the mills in Malaysia, because they don't have problems with land, so they will use pond systems that are very big, where the hydraulic retention time can be up to 100 days. Normally, it will go from hydrolysis to acidogenesis, then methanogenesis, and
so it's anaerobic. They're not aerating those ponds. There's an anaerobic decomposition going there. And that releases alkalinity as part of the process, I think.
Yeah, you're just wasting away all the nutrients that you can use for other things. When you're talking about treating it in a reactor, you can explore the production of biogas and other things that you can do. Research is exploring into using it as a feed for producing other things. I've seen work being done on using the effluent as a feed to produce hydrogen. So yeah, I think people are starting to explore what they can do with it, because having a COD value of 120,000, it's a lot of nutrients there that you can use for all sorts of things. I'm also trying to explore whether there are companies introducing cultures, specific cultures that will work with highly sugarous wastewater or highly nitrogenous, high nitrogen content wastewater. So I haven't tried that, and that's not really in my main proposal. But I think that in the later parts of the research, I would like to explore whether we can actually optimize it further by not just letting the microbes grow naturally, by immobilizing microbes that are coming from the activated sludge, but really if we could immobilize our own designed kind of bacteria and things like that, I think that would make the thing work better.
So I thought that was super interesting. You know, it's really a privilege for me to learn from a knowledgeable person like Mr. Shah, not only about palm oil production in Malaysia, but the wastewater from it and his original research into the treatment of it. I am going to be staying tuned to developments and discoveries from his work, and maybe soon I'll be able to visit him in his laboratory to see his benchtop model in operation. I sure hope so. We are going to be presenting another episode with Mr. Shah soon as well, and in that one we'll be looking at a past consulting project that he worked on with cottage-scale batik dyeing shops in Kelantan in northern Malaysia. Be sure to keep an eye out for that one. So that's it for now, everyone. Let me know what you think here. Did you know that the effluent from palm oil manufacturing was so difficult to manage? Could those extraordinarily high CBOD concentrations be a potential source of nutrients to be reclaimed? Leave your thoughts in the comments below. So, in closing, if you like what you see here on the Fount Systems Network, do like and subscribe to the channel, follow us on Twitter, and remember everyone, keep exploring, keep growing. I'll see you next time.